The effort of in the effort of in the effort of stoichiometry, this is something which is very common, that you calculate relative atomic mass, relative molecular mass, and do you have a periodic table with you right now? I told you that you should print out, if you have a printer access, you should print out some of the pages, like some test file, and they're really helpful. Like print out a periodic table. What is relative atomic mass? Relative atomic mass is the mass of an element which is dependent on the abundance of the isotopes. For example, relative atomic mass of carbon is 12. Relative molecular mass is 17 for ammonia. We remember this concept that, I repeat the concept. The relative atomic mass of an element is the measure of its atomic mass dependent on the relative abundance. Do you remember? If you have a periodic table, what is the relative atomic mass of chlorine? You can look at the periodic table and tell me.
Okay. Wait, it's not loading.
No problem. Yes, I will tell you. The relative atomic mass of chlorine is 35.5. Why it is 0.5? Why it is not a whole number? Because we have a concept of relative abundance. Actually, chlorine has two isotopes. One isotope of chlorine is 35 and second isotope is 37. And abundance is 35 chlorine exists in 25%. This first chlorine, which is 35, it exists in majority, and the chlorine 35 exists in 75%, and this chlorine exists in 25%. This is why the relative atomic mass is 35.5. Now, can you tell me? Now, can you tell me what are isotopes?
Atoms of the same element, they have the same number of protons but different number of neutrons. You write this down. Okay.
Now, ammonia. I
didn't finish.
Did you get the periodic table? Or
Yes.
so open it.
But I didn't finish writing the last line.
But no need to write it. Just like it's oral discussion. There's no need to write it. As I repeating the idea that you should print out some document. They will really help you, like periodic table, like important tests, like important tables, like reactivity series. Print them make a folder and keep them. They will be really helpful. November will go very quickly. Always people have a feel that November go on double speed and the mocks will be there. The main issue in final year mock is the pressure of the size of the syllabus. They give a lot of syllabus, and obviously you already have the syllabus with you. So I'm not sure organic is full coming from the syllabus. They are giving only till alkenes.
Yeah, I'm back.
Now, look at this orally. You have the periodic table, you open it, and I just want you to see it orally. No need to write it because you know how to do it. This is ammonia. Can you solve CO2 in this way? Find the molar mass, relative atomic mass.
CO2.
Yes.
$44.
Very good. Now NO2 similar way, H2O similar way, and molecules all apply the same rule. Now give the heading moles, a very important topic which comes every year, moles. Give the heading.
One second. Okay, done.
A mole is a measure of the amount of an element, and mole is actually related with Avogadro number. Do you remember Avogadro number?
No.
Now, remember that Avogadro number is a criteria. Avogadro number is a criteria for these things because Avogadro number shows number of particles in 1 mole of any substance. So first we find we first find the molar mass. We first have to find the molar mass.
Is that not relative atomic mass?
Huh. You can say relative molecular mass in case of molecule. And for an atom, you will say relative atomic mass. I repeat, for a molecule, it will be molar mass, it will be relative molecular mass. For one element, it is relative atomic mass. So like here, when I'm talking about chlorine, there are 2 atoms of chlorine. So I will say it's molar mass, it's mass of a mole. What is Avogadro number? Yes, Mikhail, can you tell me what is Avogadro number? 6.02.
6.0210 to the power 23.
6.02 into 10 to the power 23. Now, these are the values for it. Now, look at the formula.
Sure. 6.02.
6.02 into 10 to the power 23.
Okay, done.
What is Avogadro number? Avogadro number says that in 1 mole of any substance, there are this number of particles. In 1 mole of any substance, there are 6.02 into 10 to the power 23 particles. Number of moles is equal to mass upon molar mass. Look at the formula, Mikhail. Number of mole is equal to mass upon molar mass. This is basically a formula which comes every year. Very, very common. And I hope you remember it. Acha, can you repeat what is Avogadro number?
It's the mole of any substance will contain 6.02 to the power 23 particles.
Good. In 1 mole of any substance. Now, how we find the number of moles? Number of mole is equal to mass upon molar mass. Now, look at this. You have to copy this.
Done.
Now, find the number of moles in 20 gram of CO2. Now, can you do this? No need to copy the question. Just tell me orally, can you calculate it?
20 gram of CO. Okay, so
Okay. So, what is the relative molecular mass of CO2? 44 gram. Then you apply the formula and put in the values.
20 divided by 44, 0.455 mole. Okay, done.
How we find mass? If we know the moles, number of mole is equal to mass upon molar mass. So mass is equal to number of mole into MR.
Mass
Now, my next formula for, acha, you have to copy this also, Mikhail.
Numbers.
Let me know once you have copied it.
Mass is equal to number of moles into done.
Now, second formula, number of particles is equal to number of moles into Avogadro number. Now, Avogadro is a constant which should be memorized. Our course says that number of particles is equal to number of moles into Avogadro constant. Number of moles is equal, number of moles into Avogadro constant. Particle is equal to atom or molecule. Anything can come in this title. So you have to now, you have to copy this screen also in your notes. Formulas should be memorized. Let me know once you have copied it.
And
Okay. Now these are the two formulas. We have to continue this stoichiometry, and stoichiometry means chemical calculation. The first thing we have discussed is the number of moles. How we calculate the number of moles. Now I'm starting the I'm starting the next title, reacting masses. This is a very important title. It comes regularly. It is it is related with the formula and the equation. I repeat, acha, you give the heading. Now give the heading, reacting masses. Give the heading, reacting masses or mass calculation.
okay, done.
Now look at this. Step 1. Convert the given mass into moles. This is called mass calculation. Convert the given mass into moles. Number 2, balance the given equation if needed and use the molar ratio. Step 3, convert moles to mass back. Now, this is a 3-step procedure. Obviously, we have to do some questions, then you will understand it, because obviously a science subject doesn't go on theory steps. So now we have to discuss a question. Let me share the file with you. First of all, read the question. I'm sharing the file. Read the question from the screen.
Mass of hydrogen produced. Do you use this formula, mass equal number of moles in the relative atomic mass?
You can say that it is basically, let me start. I'm sending you the file, and if you have a parallel device, you can open it there, or at least write in your notebook, refer to the worksheet. So you should know that from where these questions are coming up. Huh? So write in your notes register, right there, refer to worksheet. What mass of hydrogen is produced when 192 gram of magnesium is reacted with hydrochloric acid? Have you read the question?
Yeah.
Okay, now what is the procedure? Repeat the procedure.
But the given mass and moles. Solve a question.
Okay, now let's read the question. I'm making the data. So write question number 1. No need to copy the question. Just start the data with me. Mass, molar mass, and mass of HCl is required. Okay, now look at the step number 1. Okay, number of mole is equal to mass upon molar mass. Mass is given 192, molar mass is given 24. I got number of moles as 8.
How is molar mass 24?
Sorry?
Magnesium's molar mass. Oh yeah, 24.
Hmm.
Okay, continue.
Now equation.
Okay.
Can you see the balancing 1:1 between magnesium and hydrogen?
Yes. What is that for? considered 1:1.
1:1. Then now when I have magnesium has 8 mole, how many moles hydrogen will have? The ratio is 1:1. So magnesium is 8. So logically, hydrogen will also be 8. Can you understand it?
Shouldn't the mass of hydrogen be 2? I mean, the number of moles.
No, but first look here. Look here from here. Okay, now, uh, I think there is a little confusion. The moles you got are for magnesium, right?
Yeah.
Now put the moles of magnesium and find the moles of hydrogen.
No, I'm saying like for the ratio, you wrote 1:1. Shouldn't hydrogen be 2?
Why? 1:1. 1:1 means if magnesium is 8, how come hydrogen be 2? What is the meaning of 1:1?
Number like H2.
No, no. Do not look at that too. Hydrogen is overall 1. No,
So,
you are not actually, there is still some confusion. Look, you have to see this number versus this number. Now, if I make it 8, how much this will be?
but like that's my question. Like, so like the ratio is 1:1. So for which atom would it be different? Like, what if hydrogen was 2? Or
That if there is a 2 here, then it will be ratio will be 1:2,
okay,
and then it will be 16. If there is a 3 here, then it will be 1:3, and then it will be 24.
okay.
Now, what will be the moles of hydrogen?
8.
Yes. Now convert the mole into mass of hydrogen.
Relative molecular mass is the one in the periodic table, right?
Hmm. Relative molecular mass is coming from the periodic table. Hydrogen is 1.
Okay, so okay, clear. I'll write this down.
You have to complete the working.
Sorry?
You have to complete this working till step number 3.
Isn't it done?
Okay, good.
Wait,
I'm
no,
putting my second question. Okay, have you done it?
no. I was saying, isn't the equation finished? I'm not finished.
Achha. The question has finished. Let me know once you have completed the work.
Okay.
Okay. Are you done?
Was on the last step.
Mikhail, are you done?
Just I'm like writing everything in detail. 1 minute. Okay, now I'm done.
Hmm. Now look at the second question. What mass of oxygen is needed to react with this much gram of sulfur? So start this question now. Read the question and start it.
Wait, don't show. can you show the next step? Can you go to the next step? Yeah. Next step. Can you keep next step?
Are you there? Hello?
Yeah, hello.
Are you able to hear me? Because I was asking you that are you getting the same number of moles?
Yeah, I think you're on mute. Yeah, I got the same number of oxygen moles.
Okay. And did you understand molar ratio step 2:3 and cross multiply? Because this step was not clear to you in the previous question. Look at this step.
And now mass. Mass is equal to number of moles into MR. Mass is equal to 0.375 into. To find MR, do I just do O2 or do I do from the equation 3O2?
You have to do always from the equation.
Okay, 3O2.
You have,
So
first you see how many moles of oxygen you are getting.
I got 0.375 and then 16 to 32, 3, 2. I got my final answer has 36 grams.
gram.
Yep. No, see, that's what I asked. 16.
Acha, oh, right. Actually, oxygen as a, here he's using the word oxygen. So it will be 16 because he's not using the word oxygen gas. So when he uses the word oxygen, you just have to take 16. Now I got it. No problem. This is our first class on stoichiometry.
So isn't oxygen O2? So wouldn't it be 32? But it's 16.
16 is oxygen molar mass, na?
So if it's an oxygen gas, then what? 32?
No, acha, first I got your point now. Can you look at the periodic table? What is the mass of oxygen there?
16.
Yes. When he says the word oxygen, just take the number of the periodic table for any gas like chlorine, like bromine. They all exist in two. Acha, when he says oxygen gas, chlorine gas, then you should think about multiplying it by 2. Then it would be O2 will be 32.
Okay, I'm done. 6 grams.
What mass of potassium oxide is formed when 7.8 gram of potassium is burned in oxygen? Now look at this question.
Okay.
Now let's start, Mikhail. Now try to do it yourself with me also. Mass is 7.8, molar mass is 39, mass of K2O is question mark.
Yeah. So do I do 7.8 divided by 39?
Now let's start. I got your point now. Find the number of moles first, Mikhail.
Is 4K plus O2, 2K, 2O, 4, 2.
Now you got the moles. What would be the next step? Apply the equation. The equation should be balanced.
I'm doing it 1 second. Now find the mass. Mass is equal to number of moles into MR mass of 2K 2O is equal to 0.1 into potassium oxide is what? K2O?
K2O. Potassium oxide is K2O.
K2O. So K2 39 into 2. Into 2, 4 into 16. Into 39 into 16. Into 39 into 16. 9.4 grams of potassium. I got 9.4. Done.
Railway lines are welded together by the thermite reaction which produces molten, but mass of iron is formed from 1 kg of iron oxide. You have to be a bit quick because we are getting the time is finishing. You have to see question number 4. I have shared the file with you. Okay. So you have to quickly make a data.
So can we do this next class?
Can you finish it at home after the class at home whenever you get free?
Okay.
Okay, so take it as a homework and let's try to finish this question in our next class tomorrow morning, inshallah. Okay, Allah Hafiz.
Allah Hafiz.